Hello everyone, I'm MD Jahidur Rahman, PhD student at University of Quebec and Abita. The control of frequency in the power system become more difficult due to the increasing penetration of renewable energy sources. Therefore, a more effective control technique is needed to avoid network collapse during the power distributions. A large amount of wind power need to dump in a secondary dump load bank to maintain the network frequency as well as the total load demand, which is not a good idea. Without throwing the large amount of wind power in the dump load, a secondary storage system has been used to charge when the power from the wind turbine is more than total load demand and discharge when the wind power is less than total load demand. It has been shown that the fuzzy logic controller gives better performance compared to the PID controller. So, to measure the network frequency, a three-phase PLL has been used. As the input of PLL, the system voltage is applied to get the frequency error. The network frequency is compared to the reference frequency. Then the frequency error is integrated to obtain the phase error. And finally, the phase error is applied to the PID controller to have the PWM signal. So considering the non-nullities of the system, we have proposed the fuzzy logic controller here. So as the input of fuzzy logic controller, we have here the frequency error and the derivative of the frequency error. And finally, we will have the PWM signal for the network. Using the power sharing method, the network frequency is regulated here. So for the scenario 1, we have 200 kilowatt power from the wind turbine. And for the due to the extra load, we have seen some fluctuation in the wind turbine, but using the PID controller, it improves. Here we have battery power that is charging, and after that, the secondary load is absorb the rest of the power to regulate the frequency. So due to the extra load, the frequency drops significantly, but using the fuzzy logic controller, the frequency drop is improved here. The transient time of also improved using the fuzzy logic controller at asynchronous speed generator. For the scenario 2, we have seen we have 200 kilowatt power from the wind turbine, but due to the extra load of different type, we have seen here, we have seen some fluctuation in the wind turbine, but using the fuzzy logic controller, the fluctuation behavior of wind turbine is reduced. So as this condition, the battery is discharging here to maintain the network frequency as well as the power. So rest of the power will be absorbed by the secondary dump load to regulate the network frequency. So due to the extra load of different type, the frequency is dropped here using the PID controller. But using the fuzzy logic controller, we have seen the frequency is improved as well as the transient type of the frequency is improved as well. Here, the asynchronous speed of the wind turbine is significantly reduced using the fuzzy logic controller. As a scientific impact, reduce the transient type of wind power flow and fluctuation behavior of frequency compared to the robustness of fuzzy logic controller over the PNT controller to reduce the fluctuation behavior of frequency in the network. Design a control scheme to share the power between the network using a logical diagram. So we have published one IEEE journal in EPEC and submitted one journal article in Canadian Journal of Electrical and Computer Engineering. Thank you so much for your attention.